Write the partial fraction decomposition of the rational expression x minus 1 over x times x plus 3 squared. Now, for the x term, since this is completely factored out, the partial fraction a over x corresponds to the factor x. But for the factor x plus 3 squared, we need to do a factor of x plus 3 and then a partial fraction factor of x plus 3 squared, since the degree of the x plus 3 is 2. So this is what our partial fraction decomposition is going to look like, and now we need to solve for a, b, and c. So the first thing I want to do is multiply both sides of the equation by the LCD, which is x times x plus 3 squared. So I want to multiply both sides by x times x plus 3 squared. Now on the left side, the numerator cancels out with the denominator here, so what we're left with is just x minus 1. And on the left, on the right, what I'm going to do is I'm going to distribute this LCD to each of the terms, and then I'm going to reduce later. So on the right we get a times the LCD, x times x plus 3 squared over x, then b times x plus 3 squared over x plus 3, and then c x plus 3 squared over x plus 3 squared. And now we see what we can cancel out. So we got x's here we have in common. Here we have a factor of x plus 3 that we can cancel out, so we can just take the squared out, and it's just going to be a factor of 1 there. And for the c term, all the x plus 3 squared cancels out. So what are we left with? We're left with x minus 1 is equal to a times x plus 3 squared plus bx, x plus 3, plus cx. And now, since we want to come up with a correlation, what we want to do is to simplify the expression on the right. So let's work on that. So foiling x plus 3 squared, we get x squared plus 6x plus 9 plus b, I'm going to distribute this x, just the x, into the sum. So we get x squared plus 3x and then cx. So now I'm going to distribute the a and b into their respective sums, right? So we get ax squared plus 6ax plus 9a plus bx squared plus 3bx plus cx. Okay, so now the next thing I want to do is I want to group all the terms with x squared in them, and then all the terms with x, and then all the constant terms. So these x squareds, we have these two terms that have x squared, right? So what I want to do is combine them and factor out an x squared at the same step. So this is going to be a plus b times x squared. And now I want to do the same thing with the x's. So we have 6ax, 3bx, and cx. And when I factor out an x, what I end up getting is 6a plus 3b plus c all times x. And then finally we have a constant term here, which we'll just write at the end. And now notice that these two expressions are supposed to be equal, right? So what we have to have is that this constant term 1 has to be equal to the constant term here. And the coefficient for this x term here has to be equal to this x term here. And more importantly, this a plus b term here, a plus b times x squared, has to be equal to 0, since there's no x squared term on the left. So let's start solving. Since it seems like this negative 1 is equal to 9a seems like the easiest thing to solve for, then let's do that first. So the coefficient on the left is negative 1, and that has to be equal to the constant coefficient on the right. So 1 is equal to 9a, and then dividing both sides by 9, we get that a is equal to negative 1/9. Okay, great. So we found our a. Now the next step I want to use is to find another letter. And since we have a, and we know that a plus b has to be equal to 0, we can use that to find b. So a plus b has to be equal to 0, but we know what a is. So since a plus b has to be equal to 0 and a is equal to negative 1/9, that means b has to be positive 1/9. And then finally, the last step is to plug in our a and b into this third equation here that we have for x and equate it to the coefficient of x on the left, which is just 1. So we know that 6a plus 3b plus c has to be equal to 1, right? Because on the left it's just 1 times x, so on the right it has to be 1 times x. But since we know what a and b are, let's plug them in. So 6 times negative 1 over 9 plus 3 times times positive 1 over 9. 3 times positive 1 over 9 plus c has to be equal to 1. So we get negative 6/9 plus 3/9 plus c is equal to 1. And I'm going to simplify these two fractions. Since they both have a common denominator, we can just combine the numerators. So we get negative 3 over 9 plus c is equal to 1. So c is equal to 1 plus 3 over 9, which we can reduce, right? 3 over 9 is equivalent to 1/3. So c is equal to 1 plus 1/3, and then finding the LCD, which is 3, this becomes 3/3 plus 1/3. So c is equal to 4/3. So then going back up here, we wanted our partial fraction decomposition to look like this, right? So our result at the end is going to be x minus 1 over x times x plus 3 squared is equal to a over x plus b over x plus 3 plus c over x plus 3 squared. And plugging in the values we found for a, b, and c, our solution becomes, let me fit it down here since I'm running out of space a little bit. A is negative 1/9, so we get negative 1 in the numerator over 9x. B is positive 1/9, so we get 1 over 9 times x plus 3. And then c is 4/3, so in the numerator goes the 4, and in the denominator goes the 3 times x plus 3 squared. So this is the partial fraction decomposition for the rational expression x minus 1 over x times x plus 3 squared.